In this problem, we are given the following capacitors. We have C1, C2, and C3, and what they're equal to right here, here, and here. We are also told that the radian frequency of the driving source is 69,149 rads per second. We need to find the equivalent impedance of this series combination, and we can do that with our Z. If we look in the notes section V-I relationship for a capacitor below the like button in the description, we can see that we do have a formula to find our Z, and that is that our Z is equal to negative J, and this is over omega times C, and omega is measured in rads per second. And we have our C given to us right here. However, we have to combine these all together because we need to find the C equivalent. So to do this, we know that capacitors in series uses the same formula as resistors in parallel. Now we're going to plug everything into this bottom equation. We're going to rewrite this as Z is equal to -1 because we already have our J right here. And then this is going to be over our omega C.